product management, and right now we are in front of the vacuum potting station. So my first question is, what are applications of the station, and what is made here?
Safety relevant applications such as autonomous driving require performance and excellence. Therefore, potting under vacuum is the method of choice. Key reasoning for that is that any bubbles in the dispensed materials can be avoided and hence full functionality is given. Now let's go to the example of the potting by itself. What I've brought with is such a piece of a connector which is dispensed. While having it dispensed under vacuum, you can avoid any intrusion of damaging particles. Let's think about dust, let's think about water, and hence it is IP protected. Furthermore, you can avoid bending of the pins, and with that the optimum functionality is given. Just think about the difference whether a car stops or whether a car runs. With the equipment from Scheugenpflug, the car runs.
Well, Thomas, I'd rather like my car running. So my next question is, what typically happens in vacuum potting?
If you want to pot under vacuum, what you have to do first is to place the product to be potted into a vacuum chamber, quite reasonable. Then what you apply, you close it, then you apply a vacuum, and then you start to dispense. The benefit of doing it under vacuum is that the material, the lowly viscous material, even flows in the smallest cabinets. And hence that leads that all the functionality requirement is given, there are no disturbances, the product can perform perfectly later on in its application.
Okay, so you talked about dispensing, but where to obtain the material from?
The material is fed through lines from the material preparation and feeding station. In this, from Scheugenpflug, it is the liquid prep, which performs the usual applications as steering, circulating, heating up, and evacuating the material.
Okay, but as far as I know, this is standard from your side. Where are the news, Thomas?
What we have here for the first time is that we really can measure the gas load inside the material. That was up to now not given and is by every means new. What we've done to measure it, we've taken measurement principles from other industries and applied it for the first time to this dispensing industry. What is done, the measurement devices by itself are hooked up to the dispenser where it is needed to have an understanding of the gas load. The benefit from that is that for the first time by objective means you know the gas load, and from that you can derive when to start production. Yes, what here we see by objective means how large the gas load is inside of the material, and that's what is about to need to know. When we start with the process, it's like a speedometer. We have a high gas load, starting with a high gas load, and then it develops down to a lower gas load, and once we arrive at the green area, then we have the perfect conditions for starting the dispensing. Hence the gas load is at such a minimum that we can avoid any bubbles in the systems, we can avoid a large air intrusion, and hence for perfect products the production can start.
Okay, and what is the status of the development?
What we have shown here for the first time, that this method applied from other industries to this industry works. We've tested it with different kind of materials. Just think about polyurethanes, epoxies or silicons. What we have to do furthermore to arrive at further tests, to have a more extended database on that, and also to improve some work modi. Here is work in progress for being able to launch it to the market. What our goal here was is to take you with us to the journey, and be assured we'll keep you informed and posted about the status of the product.
That sounds amazing. Thomas, thank you very much for the demonstration.
Thank you very much, Claudia.